Hey guys, welcome back to this new episode. In this video I'll be talking about Vpython. Vpython is another visualization tool that work hand in hand with Python. So today I'll be showing you how you can create different 3D objects, simulate them to their motion, and then and some other stuff. Okay, so let's get started. I'm assuming that you already have Jupyter Notebook, and then within this environment Vpython is already installed. If you don't know how to do that, you can just do the pip command install then Vpython, or even when you're on Jupyter Notebook, you can just go to the terminal window and then do the conda install command, and then install Vpython, then it will be running. So in this case I'll begin by importing Vpython, and when I do that, then I'll try to show you how you can play with the different objects and in 3D. So I'll begin by from Vpython, from Vpython import everything. Okay, so here I'll try to show you around. For example, if I wanted a sphere, how I can do that. I can maybe call it a ball, equals a command is sphere, and then within this object I need to insert or input some different like arguments, like for example the position, which axis, and then the size of the ball, like in terms of defining what is its radius. For example, I'll begin defining its position. The position takes on a vector form, so vector I can begin at -2 along, that is x coordinate, and then y I can say this is 0, and then z is 0. Okay, then I can go further and define the axis. Axis again is a vector, so I can say vector, let it be only in x-axis, so I'll have 1 and then the rest is 0, and then I can go ahead further to determine what is my radius. My radius by default I think is 0.5, I think, maybe it has a default value, but in my case I'll specify the radius to be maybe 0.3, and then we can also define the color. What color should the ball be? So I can say color equals color dot red. Okay, so when I do that, and then I'm done with specifying the different properties of my ball. Then I can, if I run that, sometimes it can take some time, long time for Vpython, but then finally it works. And then usually all what I know with so you can see that we have a ball here at this given position of -2, 0 and 0 axis along the x-axis. Its radius is 0.3, so when you change that, the radius or the size will be changing, and then color will be changing as well. So now there are some buttons that you need to get familiar with. The mouse button, the center button. If I try to zoom in and out, this is what we have, and then if I right click, this is what is happening. And then if I want to displace it from one position, like to move it from one position, then I can press Ctrl and then the left, then then if I press the center button again, it is almost doing the same thing. So now basically this is how you can have the different objects. Let's say we have we need an ellipse. Ellipse almost is the same thing we do, and the cone is almost the same thing we do, but you only need to make sure that you make a change in some of these specifications. Okay, so I'll show you around how The same thing to do with the text. For more of this information, you can visit Vpython website, and then you can learn more about which commands perform which type of tasks. But in this case, I'll be showing you how you can do a simulation of both the wall. The wall can be in terms of a box, but then you can choose the dimensions, for example, the width, the length, and the height, and specify them accordingly. So let me show you how I simulated a ball and a wall when it is moving through the wall. So here, as you can see, I begin by importing Vpython, and then I specify my x, y, and z coordinates, and then also I have the x for the ball, and then y, b, and z for the position coordinates for the box. Yeah, and then I have xa, ya. These are axis coordinates, as we will see, and then this is the velocity for the ball. As you can see, I specified to have x speed of 10 in x, and then the rest is 0. That means I need it to be moving only in x direction. So now, writing my ball object, I have a sphere, color red, and then position vector, that axis, xa, ya, za, which I already specified up, and then the radius to be 0.8. Okay, now in regards to the box, okay, box object, command for the box, we have it as a box. Okay, and then the color is blue, position is specified by xb, yb, and so on, which is already specified up here. I want it to be at 1, the rest is 0, and then the axis of the should take on the same thing. I want it to be moving in x-axis. That is why I set ya and za to be 0. So likewise, the size in this case, because it takes on width, height, and then length, it's kind of a vector that I'm constraining to be 0.5 in x, 10 to be in the y, and then z to be 10. So how Vpython considers the dimensions, it considers this to be the x, towards me to be the z, and then upward to be the y. Okay, so I'm letting the height and the length to be a bit larger compared to the thickness, okay, which is the x-axis in this direction, to be 0.5. So now let's try to look at the velocity, since I want to simulate a ball moving and passing through the wall. So I need to have a velocity vector, which is the xvb, yvb, and zvb, which is already specified up here, and I'm constraining it to be moving only in the x-axis. So the delta t is 0.5. Okay, when I have this, then let's try to look at the ball position as it is changing with respect to the velocity and then the time. So we have the ball dot position, because I want the position to be updating at each point, equals plus ball position plus b velocity times delta t. So this equation is going to help us to be updating the position of the ball as the time elapses. And then initially I'm setting my t equals 0 to initialize time, and then I have my while loop as for t, while t is less than 0.5, and setting the rate at which the ball should traverse through the x-axis to be 10, and then I have this. So when I do this, so that the time keeps on adding by delta t, updating, when I run this, all I know with Vpython, with my computer, I'm not sure if it is Geno, every time I run Vpython, I have to restart the kernel and then to be able to run it again and display the image or whatever I'm trying to work on. So before I run it, I'll first restart the kernel, and then when it's ready here, then I can run it. Okay, so it's ready. Then I can run and then see what it gives us. So as you can see, we have a wall of blue color, and then we have a ball that is passing through, which is of red color, and at a given slow speed, if I want to increase the speed of that ball, then I can just go down here in this loop and then increase the rate at which the ball at which the position is changing. Okay, so this is one of the things that we can do in Vpython, and you can try to make this to look a bit more fancy by adding some maybe text and so on, which you can do by just the text command. Then the next example I'm showing you here, again, how to do that is like a duplicate of this, building on this, and then look at something more advanced. Is the considering two balls and then two walls. The same thing happens. Is the like I already defined. I defined the ball one, and I mean ball and then ball one, and then of different positions. Radius is the same, axis is the same, different colors, and I'm letting also I'm adding in another property here, emissive. I want the color to be emissive. This ball to be emitting that type of color, and then I have two walls in box form separated at put at different positions, and then I have different velocities for both balls, and then I'm including something new here, which are the lights. So Vpython, you can choose to include in lights so that you have a light on the object, or that is changing the object, or just positioned in one position. But in this case, I'm letting my lights to be changing or to move along with the balls, or which is the object now. So when I do that, I'll just include the local lights, ball, the light, which is L, the first light that is going to be moving on ball 1 dot position equals ball dot position -2. So I can do a lot of changes here, and then for ball 1 I'm doing the same thing, and then start increasing my time by delta t. So when I do that, then and try to run this again, we can see that we have the two balls lighting up here. Okay, and then they are emitting that type of color. So when I stop that and run it again, I restart the kernel, and then when it's ready, then I will run it again. Okay, it's ready. So in this case, let's run it again, and the rate is a little bit faster. So you can see that the color, it's emitting somewhere the color. So that is due to the these local lights, and you can see that the lights are moving with the ball. So it's because I'm constraining the lights to be moving along with the balls, okay, or to be changing at the same time. And secondly, the color is said to be emissive on the ball. Okay, so that is another way of looking at that, making it a little bit more complicated. And likewise, and there's so many things you can think about. So another thing is you can look at the a bullet, for example. A bullet, you can look at it in terms of you can look at it in terms of a cone and a cylinder, like what I have here. So cylinder takes on the position, the size, which is again a vector, and then the axis, which is a vector, and then the cone takes on the position as well. You can arrange them in such a way that they can touch one another to form a bullet, which is sharp at one end. And then the vector, the size is again a vector, x, y, and z, how you want the cone to be. Yeah, you have like x, and then the y, and then the z. So this is basically the same number, like this, it's the radius up here and down here. That is why I'm letting this to be the same. Okay, and like the height of the cone is slightly or is longer or bigger than the radius, so that is why you have this value a little bit bigger. And then you have the axis, and then we have again the wall. So I'm doing basically the same thing here. Okay, and then I'm going to run it again, and we see basically what we have. It's taking a little bit longer. Well, I will stop it and run it again and see what is okay. Keyboard interruption. I'll try to reset its kernel, and then kernel is ready. Then I'll run it again. So as you can see, we have a wall and then the blade moving through. So the blade position is just changing based on this wire rope. Okay, and finally something I would like to show you here is the we have already seen the blade through the wall. Okay, something that I would like to show you here is the something I thought about, and I thought maybe it will be a little bit more interesting. Is the I have actually 9 balls in a rectangular form, and then I have 3 balls along the x-axis. Okay, one at the center, and then 1 ball at the ends. Okay, and then I have 2 balls along the vertical, one at the top and one at the bottom, and then finally I have 2 balls along the diagonals. Okay, that makes it 8 balls, and then the center ball is the 9th one. So these balls are going to be moving along towards the center. Okay, the center ball is not going to be moving, and then finally they will bounce back. Okay, let's see what happens. I'm letting the velocities for these balls to be the same, except the ones that are moving along the diagonal. Remember, I have to resolve the velocities along the diagonal to get the x component and the y component. So to do that, as you can see here, I'm setting the velocity to be the magnitude to be 30, x to be 100, r to be 0.5. I'll explain more what this means. As you can see, I'm having 9 balls. One is the 0, which is going to be the center one, and then the rest are the ones I've already talked about. We have the different positions. I thought of like if there is a way we can write a loop for this one, for all this, so that we don't have many equations, but it became a little bit more complicated to me in how we can write all these, a loop for all these changing stuff. Okay, and you can see for the axis x, y, this is along x and y, this is along only the x, and so on and so on, and then the color are said to be different as well. Now when I get to the velocity, like I mentioned, the center ball is not going to be moving. I'm only moving the 8 balls. Okay, so velocity 1, this is only moving along the x-axis, and then velocity 2 is negative, so it's moving towards the center. Okay, minus v, and then velocity v3 is along the minus v along the y, and then velocity 4 is moving in the positive sense. Okay, moving upwards. This is moving downwards. This is moving to the negative, and this is moving to the positive. Likewise, the balls that are moving along the diagonals are the ones here. Their velocities are resolved pi over 4 and so on. Okay, so now when we have this angle 45, delta t is that, so t equals 0, and then letting my t to run until t is less than 10, okay, at a rate of 5, a little bit slow. And then we have our corresponding equations. Again, I thought of reducing this. How I can reduce that? Maybe by writing a simple loop for this to iterate through all these 8 balls. But again, if you have any idea on how I can condense those equations, please drop your comment below, so that I can learn more from you. And then when we do that, I'll try to run this code and see what it gives us. If I run that, we have this, the 2 balls. You can see that this moving along the diagonal, and then we have then bouncing back. Okay, so these are some of the things that you can do with Vpython. Even more complicated stuff, especially in 3D, can be done with Python, just as a visualization tool as well. Okay, thank you for watching. Kindly subscribe and hit the notification button. Drop your comments, drop different ways that I can look at that. If there's any need that in any way you need to look at my code, just drop in the comment below and ask me to send you the code. I'll be glad to send you the code, and as well to have your comments on that. Thank you so much.